All right, so we have learned how to solve a system of equations by graphing it on Desmos and finding the intersection. You have to graph by hand as well. Then you've learned how to substitute one variable in for another. Today we're going to learn the last way, which is to eliminate. Elimination. You're going to eliminate a variable so that it's easier to solve. And then after this, you'll be able to start choosing which one makes more sense for you, or you'll start to see which types of problems match certain methods best. So what does it mean to eliminate? If we're eliminating someone from the team, we're getting rid of them, right? So we're going to do the same thing with our variables. We're going to try to eliminate X or Y or whatever the two variables are. So we have these three problems we're going to solve here. We're going to solve them by elimination. And the way you know that elimination is going to be something that's helpful or a good method to choose is when your variables are stacked right on top of each other like this. You see all my X's are in one nice column and all my Y's are in another nice column. That's going to help me add them so that I can eliminate them. So really what you're doing is you're thinking of this as like an addition problem, right? I am noticing here, if I add plus Y and minus Y, Y minus Y is 0, it goes away. That thing's eliminated, right? So this one's already set up nice and easy for us. So when I look at it, I know, ooh, I can take this out right away. It's eliminated. And I can just add the rest. Well, what's X plus 2X? That's 3X. Y minus Y is gone. I don't even need to write it anymore. It's eliminated. And then my last step is 7 plus 2. Well, that's 9. So now I have 3x plus 9, or 3x equals 9, sorry. And I just need to solve for x. Okay, I can do that. Easy peasy. Divide by 3. Divide by 3. Cancels out, and I get x equals 3. And then now all I need to do is find what y equals, and I can just plug it into any one of these. So if I pick the first one, which is x plus y equals 7, right? Let's just plug in my 3. So instead of x, I'm going to write 3 plus y equals 7. And that means when I solve for y, which I subtract 3 from each side, I get y equals 4. So my solution to that system is 3, 4. We eliminated that y to start off with, and it helped us solve it. So let's look at number 2. I'm looking at it again. It's set up nice for me. All my x's are in one column, all my y's are in one column, and my constants are on the other side. I'm going to just look at it. I can see 2x minus x. That'll leave me with an x. But minus 4y and plus 4y, that's going to 0. I can eliminate that. So I'm going to use elimination here. Let's just add them. 2x plus negative x, or 2x minus x, is just x. Negative 4y plus 4y is 0. That's eliminated. Now I just have to figure out the right side of the equation. What's 2 plus 3? That's 5. Oh, that one's even easier because I just came away with x equals 5. So I don't even have to do any of this that I had to do up there. Now I'm going to pick which equation I want to plug it back into, right? I can choose either. I'm going to choose this bottom one because I don't have the 2 next to the x. So I'm going to just write it over here so you can see it. Negative x plus 4y equals 3. And instead of an x, I'm going to plug in a 5. So it becomes negative 5 plus 4y equals 3. Move that minus 5, add 5 to each side. So I get 4y equals 8, right? I'm just not showing you that step of adding 5 and adding 5. When I divide by 4, I get y equals 2. So my solution to this second example is x equals 5 and y equals 2. All right, I'm going to show you one more. Okay, I'm looking at it. My x's are lined up, my y's are lined up. So I'm going to use elimination. It looks like it's going to work here because I can see right away this 2x minus 2x is going to eliminate, right? That goes away. Perfect. Now let's do 3y plus 2y. Well, that's 5y equals 1 plus negative 6. 1 minus 6 is negative 5. So when I come over here and I solve for y, divide each side by 5, I get y equals negative 1. And now I'm going to go back and think about which one of these is going to be easier to solve. doesn't look like it really matters. So I'm just going to pick the first one, 2x plus 3y. And instead of writing y, I'm going to put in -1. And it has to equal 1. And I solve that. I get 2x minus 3 equals 1. Move that 3 over by adding 3 here, adding 3 there. So then I get 2x equals 4, which leaves me with x equals 2 when I divide each side by 2. So my solution here is x equals 2 and y equals -1. And remember, you can always go back and check, is this the right answer? I can go back in and plug them in here. If I plug in 2 for x and -1 for y, I should get 1. 2 times 2 is 4, yep. Plus 3 times -1. So 4 plus -3, yes, it is 1. So that's how I know my answer is correct. You can also graph it and make sure it crosses at that point. So those are easy examples of when you see the things stacked up nice and easy like that, you're like, ooh, that's elimination. I don't even have to think about which one's easier because it's already set up for me. Sometimes, though, it's not set up, but you can still use elimination pretty easily. So if I look at this, I'm going to just take this second one and write it under this one. And you can see they are stacked up nice and easy. I got my x's there and my y's in the second column. But what is not working out is if I add x plus 2x, I get 3x. If I add 3y and 2y, I get 5y. So nothing's getting eliminated. But I can use some multiplication to eliminate something. So what do I mean by that? Well, for example, I can see if I had this become a -2 here, this would go away. Then I can eliminate the x. So how could I get that to be a -2? Well, I could multiply it by -2. But I can multiply the whole thing by -2. I can't just multiply one part. I have to multiply this whole thing times -2. And you're allowed to do that because it's just like you're solving an equation. As long as you do the same thing to each side, you can perform that operation, right? So as long as I double every number, I'm okay. So let's do that. So then I would end up with x times -2. Well, that's -2x. 3y times -2. Well, that's -6y. And then equals 7 times -2 is 14. Why did I write that? I don't know. I'll just write it like this. Well, -14. That's why I wrote that. I was knowing in my head it was negative. So all I've done is rewrite that first equation using this times -2 multiplication factor. And now I'm going to do is rewrite that second one underneath it. I didn't do anything to that one. Okay, and now my equation is set up nice and easy so I can use elimination, right? These cancel out. That's what I wanted to happen. -6y plus 2y is -4y equals -14 plus 6 is -8. So when I solve for y, divide each side by -4, I get y equals 2. Go back in and plug it in. I'm going to use the original equation. So I'm going to write x plus 3 times y. Well, I know y is 2, so I'm just going to plug in 2. Equals 7. That means x plus 6 equals 7. So when I move that 6 over, -6 minus 6, I get x equals 1. So my solution is 1, 2. So there's really only one extra step here, which was to make my equations to have one variable eliminated, I could use a multiplication factor of -2. So sometimes you can do that. You can see this pattern, go, ooh, that'll be easy to fix. Let's see. Let's try this one. Okay. So sometimes also, I want to let's focus on this one here, and then we'll go over this one live. Well, maybe I'll do both. Let's see how much time we got. So if I start here, 8x minus 2y equals -8, 5x minus 4y equals 17. I'm thinking I want to eliminate y because I got my x's lined up and my y's lined up. Okay, but none of them cancel out. But looking at this, I know I could make these cancel out if, first of all, one has to be positive and one has to be negative, right? Right now they're both negative. But if this was positive 4, it would cancel out with negative 4. And how could I make that y have a positive 4 in front of it? Well, I could multiply it by negative 2. And then what would I have? I would have negative 16x. Negative 2 times negative 2 is positive 4y. And it would be equaling 16. And then if I write the other equation underneath it, you can see now that my y's would cancel out. So I can eliminate and use that strategy. I'm not going to solve it. I'm just showing you that's how you can solve it. Looking at this one, what's the best way to solve it? So here I have y equals this, and then this side I have 2x plus 2y equals 10. So looking at this one, this is set up nicely for substitution. It's already telling me y equals something. So I'm going to substitute. But some people, what ended up last year, there were some students who loved to eliminate, so they always rearranged because you can always use either. It's just sometimes one is easier. So in this case, I would stick with substitution. But let's say you're a big fan of eliminating and you wanted to do that. Well, you could rearrange this equation, right? I could subtract x from each side. So I would have y minus x equals 13, right? If I move that x over. I'm trying to make it look just like this bottom one. So now I need to write the x first. So then I would write it as negative x plus y equals 13. Now it is set up to match this bottom equation nicely. See that? So now I could write it underneath here as 2x plus 2y equals 10. And now I can eliminate, right? I only have to do one extra thing, which is make them cancel out. And right here, you can see already, if I put a 2 in front of this x, they'll eliminate. So I'm thinking I could just multiply this whole thing times 2, and it'll work out. So if you are a fan of elimination, you can always rearrange your equations to eliminate. Okay. And then I'm going to do one more in this corner before we end this video, because sometimes this happens too. Sometimes you end up with something like, let's say this. 3x plus 4y equals 7. I don't know. And let's say this is negative 5x plus 11y equals 2. I don't know. So let's just say that's your problem. You're looking at it and you're going, okay, well, it's nice and lined up for me. So I feel like I want to eliminate. But then I look at these and I can't like multiply 4 by something to get 11. And I can't multiply 3 by something to get negative 5. How's this going to work? Well, you can multiply both equations. What do I mean by that? Well, I could say, well, I'm going to make this a positive 15. So to make that positive 15, I'm going to multiply everything by 5. And then I want to make this bottom x a negative 15. And the way I'm going to do that is multiply everything by 3. So what happens? This becomes 3x times 5 is 15x. 4y times 5 is 20y. And then 5 times 7 is 35. And then same thing for the bottom one. Now let's multiply this whole thing by 3. That becomes negative 15x plus 33y equals 6. And now I'm set up to eliminate, right? Because 15x minus 15x right here, that's going to cancel out. So I just wanted to show you that when you're eliminating, sometimes you can just multiply one equation by a factor, and sometimes you can multiply both, and that's how you'll get it to work. Okay, we'll practice some today and tomorrow. I'll see you next time. Bye-bye.